So the talk title is a little bit of a bait and switch. That's probably good enough. Anyway, first and foremost, if you're having trouble seeing it, the presentation's online. If you're not having trouble seeing it, don't go there. There are a lot of images, and I don't want you to bog down the Wi-Fi. Anyway, so this is actually more accurate. So I'm going to be addressing jQuery directly, and I think it sounds like it's kind of a popular opinion here to bag on jQuery. Hopefully, that doesn't sour you on the talk. To be more accurate, this is sort of faster, better, leaner jQuery in certain aspects. The slide just doesn't really fit real well on the slide. It looks kind of ugly. So this is my personal information. That's where you can find me on Twitter. That's my blog, GitHub. There is more stuff on my blog about this, and I'll talk about that in a little bit. But generally on the internet, you can find me at John Bender. I work full-time at Adobe on jQuery Mobile. I say that only because I'm very lucky to have a job working on open source. I'm very grateful, and Adobe pays me to work on a great project, so I'm happy to be doing that. So what is the motivation for this talk? So this is something I feel like I have to cover. A lot of people ask me, like, why do we care? What does this matter? So just to make sure that you don't leave the door in the next 5 minutes, let's talk a little bit about the motivation. First of all, math is pretty awesome. So I've had kind of a tumultuous relationship with it. And I think a lot of people have. I think a lot of times you come to math in terms of like calculus or geometry, and these things aren't necessarily very interesting. But once you find something you really love and you find a way to kind of apply formalism to it, math takes on a kind of a different shape. So that's a little bit what this presentation is about. jQuery is popular. So this is not something I need to repeat too often, but jQuery gets used by a lot of websites. According to Alexa rankings, for whatever value you give that, the top 10,000 websites, something like 50% of them, 50+% of them use jQuery. Of the top million, it's like 45%. So there's a lot of people using jQuery. So if we get a big benefit out of this, if the application of category theory and formalism to jQuery provides some sort of benefit, there's a broader win there. Everybody likes performance. So a large portion of the benefit that we get out of applying category theory to jQuery is performance, right? So everybody likes presentations about performance. Incidentally, that's a tachometer. That says nothing at all about how fast you're going. So jQuery. Let's talk a little bit about the problem we're going to kind of solve within jQuery. So jQuery, if you've ever used it before, which I'm sure, how many of you have not used jQuery? OK, there's a couple of you. All right, good. I'll make this quick, but I'll cover it. So with jQuery, what you're generally doing is you're getting elements out of the DOM using something like this, a selector with a dollar function. And then you may call some method foo on it. This could be anything, add classes, remove classes, change properties. And it's chainable, so it's a fluent interface. And this will become relevant later. So the internals of these jQuery methods all have the form. So if you're defining foo, they all take the form on the jQuery prototype. So if you're invoking it on a jQuery object, it's not actually calling anything on the jQuery object. It does a prototype lookup, right? So it goes up the prototype chain to find that function. But they're all invoked on a jQuery object, right? So the context in which they're operating is a jQuery object. And that's very important. That'll become relevant later. But generally what they do is they loop over that set of elements, or they don't, and they do some manipulation to it. That's the general shape of a jQuery method. More specifically, there's a large set of jQuery methods that deal directly in manipulating the DOM elements inside a jQuery set. There are some that don't. So for example, first just truncates the set, right? It doesn't do anything to the DOM elements in it. These things do a whole lot of work. So the first thing they do is they generally handle arguments. So if you've ever used jQuery, again, if you've used jQuery before, you know that most methods have like a gigantic type union for each of their arguments, right? They take strings, they take DOM elements, they take functions for callbacks, they take other jQuery objects. They do a lot of argument handling inside the method. So this can be complex, extremely complex at times. Additionally, they also loop over the set, right? So if you're going to manipulate the DOM elements in the set, you have to loop over it and deal with it in some fashion or another. And then that's sort of the third thing that they do. They do some DOM element manipulation, right? That's mixed in there. So this isn't bad per se, especially with an example that's, what, like 5 lines. But when you actually, if the 20 or so people who were in here earlier have actually looked at the jQuery source, a lot of the methods are actually quite large. They're very complex. So this mixing, this sort of mashing together of the functionality of handling the arguments, doing the looping, and dealing with the DOM element alteration can get untenable at times. So this is kind of the problem we're going to solve. And we're going to solve it by applying some category theory. Now, when I say I'm going to work in category theory, I'm not working in monads. Okay, I know everybody has heard of a monad before. Learning how to understand monads in Haskell is kind of a cool and popular topic if you're a programmer. I'm going to talk about a much more basic introductory level type stuff. Hopefully, if you know JavaScript at all, you'll be able to get pretty much all of this. A little bit of background. Two guys, Eilenberg and McLean, were working with groups, were working with algebras. And what they noticed was there were these commonalities between algebras, the stuff that they were working in. So like any programmer worth their salt, they took what they were seeing that was the same and they abstracted it out. And this sort of became the genesis for category theory. Wild and crazy guys that they were. Because working in algebra is exciting. But that is what eventually became category theory. They just did what you do every day when you see two things that are doing the exact same operation. They pulled it out, and they made it available. So what is a category specifically? Let's start by defining what we're going to be building here today. First, it's two concrete things. It's a set of objects, just concretely things, and it's a set of morphisms, which are actions or operations on the objects, right? So a good example, and then there's two laws. First law is identity. So identity is very simple. For every object in a category, and just to be clear, so you can think of objects and morphisms as the relationship between nouns and verbs, kind of, right? I think that analogy gets overused a lot in programming, but it's very apt in this case. So the identity law is very simple. It just says that for every object in a category, there has to be some function that will deal with that object and return it, as in not do anything. So in JavaScript, this is very simple. It takes an argument, returns the argument unaltered. So that's identity. The second is composition. So this is the second law it has to adhere to. It has to provide for composition. Very simple. If you have some function g that takes an a and gives you a b, you have some function f that takes a b, gives you a c, if you smush those things together, you will end up with a function that takes an a and gives you a c. How many of you have used underscore JS? Okay, the compose function. That's what we're looking at here. So in JavaScript, again, it's very simple. Take two functions, create a new function that takes a single argument, and then pipes those through each of those functions. Again, you're just gluing the two things together. You're composing them. Composition. So this is the fourth thing that you need for a category. So let's start off. We got two categories to go through. The first one we're going to cover is HTML. Now, what I'm asking you to do for the first part of this presentation is sort of blindly follow me through the formalism here. And then at the end, we'll get to the really awesome stuff, like the performance benefits and things, the concrete things that you could take home and talk to your friends about, if you were to talk to your friends about category theory. So HTML is our first category. The objects in HTML, very simple. They're just DOM elements, stuff you get using the jQuery, or not the jQuery, the JavaScript API for the DOM, right? So query selector returns a single element from the DOM based on a selector, right? So the thing that you would get from these are the objects of the category HTML. When I say objects, I mean all possible representations, every possible DOM element ever fits into this set of objects. It's a large set. The morphisms of HTML, the verbs, the actions, are just JavaScript functions that take HTML elements and return them, okay? And in this case, we're going to say a single element. And we're also sort of hand-waving here, right? JavaScript doesn't have a type system. I mean, there are compiled to JavaScript languages that do, but in this case, we're talking about JavaScript. And we're going to hand-wave and say that to play in HTML, to play part in our game here, you have to take only HTML elements and return only an HTML element. You can't take an HTML element and return a string. That wouldn't be part of our category HTML. So an example, very simple, takes an element, sets the attribute class to foo, very simple, and then returns that same element that it just altered, okay? Super simple. So identity, what is identity? What is that identity function in HTML? Again, same thing, the only difference is we're forcing it to take a DOM element and return one. That's the only difference. Same thing with compose. Compose is exceptionally simple. Again, the only difference is DOM element, not just any random thing. So that's it. That's all HTML is. So we just, in about 2 minutes, defined our first category. How many of you are totally unclear about the things I just said? Okay, right. This is how simple category theory is, right? It's not, at a very basic level, it's so abstract, it's extremely simple, right? So we can apply it to a lot of things, and it's applied all over the place in math and science and chemistry and all sorts of wild places. So let's look at one that's a little more complex. So let's look at our second category, the second part of our formalism here. is our category jQuery. So the objects of jQuery are, surprise, surprise, jQuery objects. Okay, so any jQuery object. It could be the empty jQuery object. It could be one with many elements, a single element, doesn't matter. So in the case of our example here, it's just one element, well, ostensibly one element, unless you're throwing IDs around your DOM like a madman. It's just any DOM elements wrapped by jQuery object. The morphisms of jQuery are, as you would expect, jQuery methods. So anything invoked on a jQuery object that manipulates the jQuery object is a jQuery morphism. Very simple. Identity, just as you would expect. Very simple, but there's a slight twist. So it has to be defined on the jQuery object's prototype, jQuery.fn. Okay? We're stipulating that because the requirement here, remember we said earlier that identity had to take an argument and return one right here. So here, what we're doing is we're sort of twisting that a little bit. I'm going to hand wave and say that the first argument is actually the context, the this value in this case. And if you know JavaScript well enough, you know that you can actually use function.apply and explicitly set the this value. So you can actually kind of treat it like an argument. But I'm going to hand wave here and say it's not taking any arguments, it's just going to deal with this. And that's our first argument. So how does this work? Just as you would expect, you invoke ID on a jQuery object and you get back the exact same jQuery object. Okay, simple enough. Composition. Now composition is a little more complex again than for HTML. Take two jQuery methods. Now these aren't just random functions anywhere. These are jQuery methods, things that are defined on the jQuery prototype. And we're going to create a new function that will eventually be assigned again to the jQuery prototype. And I'll show you an example in a second. But this is very simple. It's just going to take the context, the this value, and it's going to pipe it through each of these functions using apply. Is anybody unclear on how apply works in JavaScript? Awesome. This is the perfect crowd for this presentation. All right, so real quick example. If you have two jQuery methods, each of them dealing with the this value, okay, just like if you write jQuery methods and they don't deal with the this value, something's wrong. So this is what a jQuery method is. You're composing them using our compose function like this, and we get a new one, gf, and that ordering there is correct. So g will go first, then f will go. And what we're saying is that as a result, these two things are functionally equivalent. We've smashed the two jQuery methods together so that the G and the F are the same as the composed version, okay? I want you to remember this slide specifically. Remember that when I say that the composed version is identical to the chained version that we're making an example of here, I'm going to use that later. We're going to talk about loop fusion, okay? Great. Anybody not going to remember that GF is the same thing as chained G and F? Great. This is a great crowd because none of you raise your hands. So the last thing we're going to talk about is a functor. Also, if you have a better slide background for a slide that says functor on it, you let me know. I could not find one. I thought that was just a really cool picture. So a functor is a purely category theoretic construct. All it does, it's a little complex, but all it really does is get you from one category to another. So if you're playing around in HTML, you're using raw JavaScript functions to deal with HTML elements, and you want to get into jQuery for whatever reason, you want to take that stuff you're working on and get into jQuery, you need a functor. Well, you don't need a functor. I'm giving you a functor as a consequence of this because we're talking about category theory. But the point is, that's what it does. So we're going to go from HTML to jQuery. This is not bidirectional. It's unidirectional. So we're only going from HTML to jQuery. So we need three things for this functor. First, we need something that translates objects in HTML to objects in jQuery. Okay? The second thing we need is we need something that takes the morphisms in HTML, so those HTML altering regular JavaScript functions, and turns them into jQuery methods, or the morphisms in jQuery. And the last thing we need to do, there's a little bit more detail to this, but for the presentation, the last thing that we're going to do is we're going to prove the last law, which is that it preserves composition of morphisms. Okay? That sounds really abstract, but it's actually very simple. So we'll talk about that. So for the objects, very simple, extremely simple. Little known fact, or depending on who you are, if you take a regular DOM element, and if you send that as an argument to the dollar function, you get back a jQuery set that wraps that thing, right? So we've taken our HTML objects and we transported them into jQuery quite simply. All we had to use was the dollar function. Okay, so that's the first part. Second part, we got to take the morphisms, those jQuery or the HTML altering functions, and turn them into jQuery methods. So if we take our example set foo, that just alters that element and adds the class as foo. What we really want to do is we want to take something that accepts as a single argument, an HTML element, and we want to turn it into this jQuery method, setFoo, this invocation, right? So this is we're sort of changing the invocation pattern. So how do we do that? Well, one really easy way to do that is map. So inside a jQuery method, you have the this, and when you use map, it just iterates over that set of DOM elements that's inside the jQuery object and hands them off to whatever function you gave it, right? So in this case, I've kind of hand waved and I've said it's okay that the index is an extra argument. So that's fine for now. But with that, all we had to do to basically take our set foo, which was only concerned with HTML elements, and turn it into what amounts to a jQuery morphism, is apply map, right? So if you've ever done list operations in other languages, obviously you're probably familiar with map, and it's very much the same thing. A list is actually it's a functor for all lists. So that's all it's really doing here. So map becomes our second bit. So we have our two pieces, our two concrete pieces. First, a mapping from the HTML objects to jQuery objects, and second, a mapping from HTML morphisms to jQuery morphisms. Okay, so the last thing is the law, and this is actually the really important part. This actually tells us almost everything about the two categories we're going to care about. So first, remember we said that when we smush these two things together using compose to get G and F, that was functionally equivalent to the chain, right? Okay. The functor law requires that in the case where we use the underlying HTML morphism, so again, remember I said that in jQuery methods, inside them is sort of living this HTML altering thing, right? So if we pull that out and we stuck those together by themselves, and we map that over the jQuery set, that would actually be functionally equivalent to G and F, right? So it's the equivalent HTML morphism. So what this is saying is that, and interestingly enough, that top thing is 2 loops, and the bottom thing is 1 loop. So that's loop fusion, right? So, and it's still bounded by n, but that's less loops, which is good. It's less operating. You're creating less heat in your processor, so to speak. Anyway, that's what it's saying. It's saying that the raw composition using a map is the same thing as chaining those two methods. That's the law. If it adheres to the law, that's what you get for free. More broadly speaking, what this is actually saying is that there's a really kind of tight relationship between the category HTML and the category jQuery, or colloquially between stuff that manipulates HTML and stuff that manipulates jQuery objects, which I think you kind of understand intuitively. So this functor that takes HTML and turns it into jQuery, the morphisms, actually, there's a set of them that depend on jQuery, right? So remember we said that inside the jQuery methods that alter, so let's take add class for example. And I have another class here, I have another example here in a second. Inside that is living something that alters HTML elements, right? So it does two things really. It alters the jQuery object and it also alters HTML elements. So on some level it's dependent on some external thing that could just be altering the HTML elements. So that's the relationship that we got here. So a little, if you wanted to do kind of the ghetto map version or math version of this, it would be map plus these morphisms, these HTML altering functions equals some subset of the jQuery methods that you've used every day, right? So you can get all of those from map plus the HTML morphisms. So that's the relationship. As an example, so inside foo, now that we have map and this thing that alters HTML elements, like I said, there's tons of methods that do this. So add class after HTML prop, they all look like this on the inside. Now, it might be a little bit different. They might use each, they might use while, they might use a for loop to loop over the jQuery set. But they all do this and then alter the underlying HTML element. So if they're doing, remember that they're doing all these three things together, which is bad. But what we've said is that this relationship means that we can actually pull out that HTML part, right? So the relationship, the functor, between these two things is actually telling us that we can take that basic underlying alteration, and then the jQuery method can only deal with arguments and looping, and leave the alteration to the foo, okay? Leave it to the HTML morphism. So we've actually, the formalism, the category theory, aside from giving us loop fusion, has also given us a way to better architect jQuery at an underlying level when you're manipulating the DOM, okay? And that's awesome. So we're really happy because this sort of solved our problem. The formalism, the application of the formalism has sort of solved our problem for us. Great. So I've just spent, okay, so I just spent 20 minutes convincing you just to blindly follow me through math and formalism, right? So let's talk about why you actually care. First of all, a common idiom in, so let's assume, okay, and I need you to assume for a moment one thing. Let's assume for a moment that jQuery in an alternate universe, or let's say an alternate universe where I came to jQuery before a year ago, and I got all gung-ho about category theory, and I decided I wanted to go to jQuery and separate all these out so that jQuery was now providing the underlying manipulation, not as a part of the jQuery method, but as a part of a separate thing that gets used in the jQuery method. So what would you get out of this? First of all, rewrapping. So rewrapping is a pretty common idiom in JavaScript, or JavaScript that uses jQuery, right? So if you bind to a function, when you want to get the target of like an event, you use event.target, and that is actually an underlying thing. That's an HTML element, right? So you end up rewrapping this. I think you can use this in this case also. But if you didn't have to do that, or if you had foo, the thing that manipulated HTML elements directly, you wouldn't have to rewrap it, right? You could just call foo directly on the HTML element, right? Simple. You can simplify your code a little bit. There's a little less cruft. Not a big deal, just something to keep in mind. So fusion. Remember we said that this law meant that a chain was the same thing as composing the underlying alteration, right? So an example, if you have two remove attributes in a chain, that's actually, you can actually fuse this manually, and this is manual loop fusion, using the underlying thing that alters the elements. Because remember, each loops over the set of jQuery, the jQuery set, and gives you each HTML element. So you can then manipulate that directly. So now you've gone from 2 loops to 1 loop, which is good. You avoid doing, variable incrementing. You avoid doing array access and a whole host of other things, which in and of itself isn't like mind-blowing. And I don't expect you to read that up there. But the blue bar is when you're using loop fusion, when you're using the fused version. And the red bar is when you're not, so when you're just doing chaining. So there's a performance benefit. It's not huge, but it's there. I'm going to say it's between 10 and 15%. It's not. It's more like 5, but that's fine. So we get some performance benefit out of doing the loop fusion. So that has a benefit. Getting access to that underlying thing allows you to kind of smush these loops. Invocation. So in jQuery methods, there are almost always an enormous number of invocation patterns that you can use to work with the same method. So one example, the one I always kind of use, and it's actually a pretty simple example, is remove attribute. So this example is functionally equivalent to this. You can either chain 2 of them, or you can use a white space separated list of attributes that you want to remove. So, and that's cool because it means you can call remove attribute less, but there's a price to pay for doing that string parsing, right, and then removing the attributes. Okay, that's not for free. Part of jQuery's bent is that it has always been about ease of use and not necessarily always about performance, but those kind of things have a trade-off, right? So if you just go into remove attribute and you tear out that feature, you get a pretty big performance win. In this case, I'm going to go ahead and say it's 20%. But you can see, okay, the unfriendly version of remove attribute is the red bar, okay, and the friendly one is the blue bar. It's faster. Okay, it's better in terms of performance. Now, it's not better in terms of usability, right? But if we provided that remove attribute to manipulate DOM elements and we just left off all the invocation patterns, you'd get the performance benefit, and you wouldn't lose the other invocation pattern. It's just sort of a newly exposed API. It wouldn't even increase the size. So that's one other benefit, is simplifying the manipulation of DOM elements. When you don't, because you're paying, if you're using jQuery and you just use the chained version, you're paying the price for the other version in terms of performance. Okay, so what you ideally would want to do is leave that in place and provide a second API in terms of the underlying HTML morphism. Dog food. Inside jQuery, there are tons of methods that use other jQuery methods. For example, and this is a very simple example or simplified version of it, but replace with uses at least 2 other jQuery methods. So it uses before and remove or append and remove. That means that if you optimize these things, or if you were to use the underlying simplified version inside of jQuery methods, even just not exposing it at all, let's say we just decided to re-architect jQuery, the jQuery methods like this by themselves, you would actually see a performance benefit. Faster, the split version is on the bottom, it's the red, and it's faster than the blue version above it. So you get a performance benefit without actually even providing anything new to anyone else. So jQuery would benefit from this in terms of performance. Last, and probably most importantly, if you need a performance escape hatch in your jQuery code for whatever reason, now I want to caveat most of this right now with one thing. Most JavaScript performance problems in the browser are almost entirely due to things like reflows and DOM manipulation. So almost all JavaScript spends most of its time inside the browser. The execution time is inside the browser. It's not at the JavaScript level. And so that's why I want to say before you run out and tell everyone that we can fix the world's problems with these things, that has to be taken into consideration, right? At some point, JavaScript may actually become a bottleneck for you, but most of the time it's in the DOM. So before I give you a big performance number, which this is, I wanted to caveat that. So if we expose this thing and you needed it as a performance escape hatch, for example, if you're doing a bunch of element appending in your jQuery code, and this, for whatever reason, was slowing down what you were doing, you could take this and convert it into a while loop using the underlying append, right? So the previous example just uses regular jQuery append, right? Works on a jQuery object. The underlying one requires HTML elements. So if you do this with like a tight while loop, and you if you extract the elements out of the jQuery set, and then you append whatever element you're appending manually using this append, you get a gigantic performance improvement. Okay, and this is what I mean in terms of an escape hatch. Now, I don't know what the percentage is. I think you can tell that that's a big difference. So the big one at the top is the simplified one that just uses the HTML morphism directly. So that's really pretty awesome. Again, assuming your bottleneck is in that append, it's really awesome. And I think that it's a single-threaded runtime. You can always shave some time off, but how much time do you want to spend on it personally? And this is something that I've discussed with the folks in the jQuery project too, is that they have a lot of things that they need to do, so it doesn't necessarily make sense for them to spend all their time on this when most bottlenecks live outside of their code. So in light of the fact that this is actually pretty cool and that I like the idea, clearly I'm here presenting about it, and it doesn't seem like something that's really reasonable for jQuery to do up front. I work on the jQuery team, so I have contact with the jQuery core folks. They have a lot of stuff on their plate. So I decided what I'm going to do is I'm going to do this myself. I'm going to provide it as a separate library. I'm basically going to steal the code out of jQuery and provide those underlying manipulations as sort of a DOM manipulation set of macros, just some functions that make manipulation easier if you don't need anything else from jQuery. Also, I have to give credit to the folks who made Guild Wars. This is one of their images. I think it's a great picture. It fits with the slide. So I also don't want to get sued for using it. So this is available on GitHub. I'm not hitting the cat. I wasn't even sure I wanted to do this when you guys sent out the email about hitting the cat. It's not private anymore, actually. It's public, and you can take a look at it and play around with it. There's a couple things that it's meant to do. First of all, it's focused. The goal is not to do anything other than make DOM manipulation methods using the names that you're used to from using jQuery. Okay? So the idea is that there's supposed to be a pretty close one-to-one relationship. So when you say, I want to empty something, you don't have to think about what the name of the method is, right? It's just empty. And they're provided just as methods by themselves. And generally speaking, they return the element that they're manipulating so that you can do that composition if you want to. It's functional. So I am providing, the goal is just to provide the methods, sort of the internals of jQuery, and sort of expose them. But I'm not crazy. I think if you wanted to use this as a standalone library, I'm kind of trying to make that possible. So first and foremost, there's a namespace under which all these methods live. Okay, so you just empty the element. It's very simple. And it's functional. You just pass the things in. There's no objects. It's not object-oriented. It's just a method. Otherwise, you can wrap it in a DOM in a wheeled DOM object, and then do things like chaining. So there's a nice kind of fluent interface if that's what you feel like doing, if you want to use it as a standalone library. And lastly, there's a very simple selecting interface. It defaults to query selector where it's supported. But you can plug in things like Sizzle in this case. Does everybody know what Sizzle is? OK, so for those that you don't, jQuery's selection engine is called Sizzle, and it's provided as a separate library. It just gets used in jQuery. It's modular. So every single one of the methods, I think that this is old, but there's like 17 or 18 methods right now. There will probably be more. Every single one of them is an AMD module. So and this is more for the build that I have in place to construct it and provide it as a single file. But you don't have to keep any of them, right? I wanted to see it's kind of an experiment in radical modularity. It's well tested. So I have a fork of jQuery where this is actually being used in each of the methods that they're mapped to. So and it runs in the test suite, jQuery test suite, and passes. So that was one of my goals. I want it to be jQuery, but not jQuery, sort of. It's small. Smallish. I haven't made any effort at all to keep it small in terms of minification. But with the DOM stuff, like the user-friendly stuff, it's about 1.5K, and it's about 1.2K with out any of the user-friendly stuff. So the jQuery version of this, it's probably a little bit less than that. And at some point, I'll go through and make it smaller. I'll make a pass to make it a little bit tinier. And it might get a little bit bigger as I add methods. Lastly, if you're interested in more of this, I have, obviously, Wheeled is on GitHub. You can find it under my namespace. That's the link. My blog has other really nerdy stuff about category theory. So there's actually a natural transformation that lives inside of jQuery, which is kind of cool. There's almost no benefit from it, but it's fun anyway. And I am sort of getting this together in terms of like writing a paper about it. I have no illusions about it ever getting published, but there is performance information there. There's a lot of links to JS Perf there if you're interested. And that is category theory in jQuery.